Want to welcome everyone that's taking time out of their day to join us. This is, I think, our fifth or sixth installment of Corsair Chats. It's been very, very successful. I hope everyone that's tuning in is safe and healthy and everyone's adjusting well to the new normal. Definitely thinking of all you out there, and again, appreciative that you could spend time with us today. My name is Josh. I'm the Director of Alumni Relations here at UMass Dartmouth. We have a lot of things going on that we'll kind of get through at the end, but definitely don't want to take too much time and pass it over to, I guess, the man of the hour and someone who's very, very popular at UMass Dartmouth, and I'm very excited to have the opportunity to speak to him today. Scott is a 1987 graduate of the College of Engineering, majoring in mechanical engineering. He holds a Master's of Science in Mechanical Engineering with a specialty in fluid mechanics and propulsion from Purdue University. Following graduate school, Captain Tingle spent 3 years with the Aerospace Corporation, El Segundo, California, as a member of technical staff in their propulsion department or division. He was commissioned as naval officer in 1991. He was selected by NASA in 2009 and most recently served as flight engineer on the International Space Station for Expedition 54 and 55. I can't tell you how many times I practiced that so that I would not mess that up. Without further ado, I'll pass it over to Scott. Scott, thank you so much for joining us today.
Thank you, Joshua. Hey, it's great to be here. And thanks to all my fellow UMass alumni and students and teachers and friends. And it's always awesome to come back here. I was just telling Joshua earlier that I don't get back enough. And right when things were getting a little bit more manageable after my flight, that I was looking forward to coming back and catching up with all of you and my family. But then COVID hit, and it kind of put a damper on things for that. But important thing is that we're all safe, we're all sound, and we will live to fight another day here. And today we will talk about flying in space, answer some questions, and talk about the wonderful school that you go to, UMass Dartmouth. Let me see here. Okay. There we go. All right. And again, you already know who I am, and class of 1987. I'm going to show you a short video. I'm not sure how it's going to come across in Zoom. I'm going to turn the volume down, and I'll talk a little bit so that you can kind of know what's going on there. So I launched out of Kazakhstan, or Baikonur, which is in a Russian system called the Soyuz. It's a great system, but it's very tight and very small, but it does what it's supposed to do, and it gets us to low Earth orbit. It's a great view once you get there. And the station is like, in my eyes, I was going to Battlestar Galactica and flying right up and rendezvousing. And all my friends were inside. That's Sasha Masurkin, who's a MiG-29 pilot. And that was us practicing how to kill each other. And we got mission control there with a team of literally a cast of thousands that make these missions work. One of the best things up on orbit is the view. And you get to see all kinds of good sunsets, sunrises, and auroras. It's absolutely boggling to see the beauty from that perspective. You get to see a ton of stars like you'd never see on Earth, but only for a few minutes. And then the northern lights, in this case, the southern lights. And carrying cargo around the station, you got to get a little creative because you need your arms to move around. My mom asked me to do my favorite move, and that was it. We got to grow plants and food, and I actually got to eat the salad. And being a pilot, I got to do a barrel roll at least once a day. And we got a couple of guitars up there, so had a little bit of fun with that. I love to play the blues, and doing that on station was great. Staying in shape is critical. Lifting weights, riding bikes, doing treadmill. Got to keep ourselves healthy so when we come back, we can recover real fast. And of course, a healthy diet is my favorite PB&J tortilla. Doing spacewalks is extremely difficult, and but we had fun. I supported 4, and I actually went out and did 1. It's kind of cool to see all the lights and the thunderstorms and just the geography of the Earth when you have a spare minute just to look out the window. This is the East Coast of the United States. Great pictures of the moon rises and moon sets. big solar arrays. They're as big as a football field, and we got 8 of them. That was the SpaceX Dragon, just leaving after dropping us off a couple thousand pounds of food and science experiments. And we do orbits about 1 every 90 minutes, so we get to see the entire Earth every 90 minutes. And of course, the phase angles change. But we're always doing camera work up there. We're always doing science. We're always trying to fix things. The laboratory up there is second to none. It's fantastic with all of the systems that it has to do good science. And then when it's all over, 6 months later, you jump back in with your closest friends, close the hatch, depart from station, re-enter. This is a good picture of looking out the window when your bottom of your capsule's burning up. Then the chute comes out and you're like, oh, relief. And the Russian special forces coming at us. Then boom, you land and it hurts. 16G landing in 2 pulses of 8 Gs. They open up the hatch, and it's for the first time in about 6 months, you're actually smelling ragweed and dirt and all the vegetation that grows out in the desert, and you know you're home. So it's pretty cool, and spending 6 months on the International Space Station, what a wonderful, it's an engineering marvel is what it is. You look at the 8 solar arrays that it has out there. We've got several modules. We've got a couple of robotic arms out there that we use, several docking ports for Russian vehicles and American vehicles. But it takes a lot of maintenance. It's got 33,000 cubic feet of living space and travels at 17,500 miles per hour at 250 miles above Earth. And it's been doing it since about the year 2000, 2001. So for 21 years, for a lot of people listening to this presentation, you have not been alive. We've had people in space for as long as you've been alive. And there's another way to think about it. For as long as you've been alive, if you're under 21, not every human has been on Earth together, right? So that's kind of weird. But anyway, it takes a lot of maintenance. So we got to be experts on all the systems, the life support systems, the food systems, the exercise systems, the propulsion systems, the navigation systems, all of those things, just in case something happens and we need to fix them. Operations, I tell you what, you look at an airline that's running behind the scenes, you look at an aircraft carrier or anything that operates in the fog of war when things are happening overseas. That is the space station. Literally thousands of people working these programs every day, and it's very busy. Lots of science going on, lots of operational stuff going on. We got EVAs. We're doing robotics. We're doing a lot of science and research up there too. And we can't forget that the whole thing about human spaceflight is the human part. So we have to have a life. We have to live. And that includes maintaining positive attitudes and good morale. And again, one of the hardest things we do up there are the spacewalks, and a couple of quick pictures here to let you know what it kind of looks like when you're actually outside of the International Space Station. We use these spacesuits, and I actually consider this spacesuit my own little miniature space vehicle. I climb in it, and it protects me, and I go out and do work, and then I go back inside, and I climb out of it. And we've got lots of little power tools to help us do that. And technical education helps understand with all the highly technical systems that we have to get the job done up there. And it can get pretty tiring and pretty interesting. The science is incredible. We have a glove box up there where we can do some very precise science that they send up. And this is a picture of actually an experiment called metabolic tracking. So what we were doing is we were mixing 2 substances into a test tube and then putting the test tube underneath a spectrometer. One of the substances had bioluminescent cells in it. And so when you put it under the spectrometer, you can actually see the effectiveness of the 2 substances, how they mix and how they're working together. And what the punchline here is if we can do that with medicines, new medicines, we in just a short amount of time figure out how effective they are or how safe they're going to be and get them to market to the people that need them very quickly. and avoid a 2 or 3 year trial run on a select group of people. So this was done with one of the major companies on the ground, and has an estimate of having an impact to over 8 billion people. And of course, getting pictures. Whenever there's a hurricane, we got to get pictures. And I was up there during hurricane season, so we got a lot of pictures of hurricanes and typhoons. And I'll tell you what, they are monstrous. And the next time they tell me to evacuate, I'm evacuating. Got great pictures here. This is the Pacific Northwest. You can see Vancouver and the West Coast there, the Northwest coast with the sun glint. That was a really good picture. This is the Nile leading into the Mediterranean, and you can see Israel down at the bottom there. But absolutely beautiful, the beginning of civilization, and it's really cool to be looking at it from this perspective. And here we have Thailand, and all those green boats are the fishing boats, and there's a lot of them. And this is kind of a cool picture. And I've been to Thailand a few times, and I've seen all the boats out there, and I've ridden Liberty boats, through their little chain of boats to the shoreline, so that I could get off and go relax a little bit. But this, I never knew it was quite like this. I remember seeing the lights out there, but when you're on the station, you get to see all of them, and it's beautiful. It's like looking at a Christmas tree. And of course, the Straits of Hormuz that I've sailed through several times and flown over as well in my career. And of course, got to take a picture of home. There's Boston and Cape Cod, and you can kind of see up to north towards Maine and New Hampshire and a little bit of Vermont. And this is Boston at night, and you can see down here, I don't know if you can see my mouse, but down here's Cape Cod, there's Boston, and then right here's Long Island and New York City. And we always like to have some fun. And this is pretty cool here. We got my friend here on a guitar. I'm on a guitar. My commander's on a flute. We got the pan flute over here for Oleg, another one of my Russian buddies. And this is my friend Ricky, who's now a professor down at the University of Maryland. He's playing a makeshift drum. And just in case you don't recognize that, that's called a keteo. The Russians make it. And that's where we hold our solid waste. However, this one's empty. And you can also see that we're kind of plugging into a tablet with some software and applications. And we were actually jamming on a song called Gloria. It's an old 60s tune, but both these guitars were programmed to sound like electric guitars. So we had a really good space jam that day. And there's a wonderful international community. I can't ever do one of these briefs and not tell you about the thousands of people across the globe that come together. We have 16 international partners. The primary ones are typically Russia, Europe. So we get, Germany, England, Italy, all those folks. And then we also have Japan for JAXA. And next month, we actually start, in fact, we've already flown a UAE member. So we're bringing the Middle East back in. India is starting to play a little bit more. It really is becoming a worldwide program. And I just think that's absolutely wonderful that we can get everybody involved. And I think doing these missions as a race, vice a country, is really the key to success here in the future. And speaking of the future, you just probably saw in the news that we just recovered DM2, which is the SpaceX Dragon test vehicle we sent up for the first time with crew on it. And they had a successful 2.5, 3-month mission. Came back, landed in the water for the first time, and recovered them. And that starting the process. And we've got the second vehicle getting ready to go, probably looking at late October, early November for the second mission. That was SpaceX Dragon, and we expect the Boeing CST-100 or Starliner to launch shortly as well. We're thinking about going back to the moon in our Artemis program. We have a Gateway Station being built as we speak, and we're building the SLS rocket and the Orion capsule to all be part of that. And the idea is that we get into kind of a halo type orbit around the moon, and then we dock to the Gateway Station, we climb into a lander, we go down to the moon, we do some science and some investigating on the surface. Then we get back in the lander, we go back to the gateway, we kind of finish up the science, and then we get in Orion and come home. And those missions will be anywhere from 2 weeks to a few months when we finally get things working the way that we want. And the whole thing is going to all be a test bed for heading off to Mars at a time in the future. The good news is that there's a lot of cool work going on, and we need talent in all disciplines, whether it's engineering, mathematics, science, legal, public affairs, admin, you name it. If you have an interest in space, you can apply whatever it is you do to this community because it needs you for that. So there's a huge growth potential for government and commercial organizations right now for all of this that's going on. So if that interests you, then give it some thought and come on out and join the team. All right, and obviously I can't say enough about my experience at UMass Dartmouth. My takeaways are a solid foundation in engineering fundamentals. So many jobs I've had since I've left academia to that required just knowing the fundamentals. When you sit down and you try to solve a problem, it's just so much comfort to be able to sit down and say, well, I know F equals MA. Let me start from there. And then you build it up and you can come up with an answer that's pretty close to all the whiz bang engineering that all you younger folks do with all the computational, the numerical methods and the computational fluid dynamics and the finite element methods. Those are all really good tools. And having expertise in that helps. But without a good foundation in the fundamentals, I think those tools will get away from us a little bit. It's always good to have somebody that can look at the back of a napkin and see if we're in the ballpark for that. But practical application, we're at UMass, we're always getting our elbows dirty. We're always in the lab. We're always talking about how this applies. And you have a lot of professors that actually work out in town and commercial organizations and consult and do research and things like that. And being able to take the theoretical and apply it to real life problems is a skill that some people never learn, but fortunately, all of you there will for that. You also have world-class mentorship and, of course, lifelong relationships that we maintain today. Absolutely life-defining for me. And so thank you to UMass. You continue to have a profound impact on my life. It all started here for me. Okay, now I think we can go over to Q&A. Back to you, Josh.
Awesome. Thanks, Scott. That was amazing. That is great. I don't know why I can't stop smiling. So I can only imagine the ability to actually see it live, which is great. Thank you so much for sharing. What I should have said to everyone who's on here now participating, on your screen on the bottom, there's a Q&A button. It's either on the left or the bottom of the screen. You're more than welcome to just start typing away Q&As, any questions that you might have in that box, and we'll do our best to get to as many as we can in our time that we have. We have a couple that were already sent in, Scott, so I guess we should probably start there.
You bet.
Scott, please tell us about your view on leadership and how that has been shaped through your experience. If you could also touch about the importance of followerships as well.
Yeah, so leadership is one of those things that that you just assume is going to be there, and as you go through life, you start figuring out, maybe it wasn't there to my liking or to the level that I wanted. So you start looking at it, and then you're given responsibility, and then you understand why. That's easy. That's an easy mistake to make, or wow, this is not an easy problem to solve. Somebody has to make a decision on that. So it's really easy to come back and say, okay, I need data to make decisions. Okay, then it's black or white, right? If the data fills in all the gaps for you. But that's not what we need leaders for. We need leaders to make decisions on the gray areas. And 99% of the engineering problems that you're all going to work, or social problems or political problems or legal problems or administrative problems, it's all in the gray area. And so my view of leadership is, hey, first I want to know when do we need an answer and what does it have an impact on, right? All the kind of the things that are external and why this is important. Once I understand that, I'll set a timeline. all right, well, if this is needed in 2 months, I want to make the decision in 1 month or no later than a month and a half. And then, okay, so now I have a month and a half. What data do I need that will help make this a little bit more friendly or a little bit more understandable, and so that I can have the greatest impact on the most people in a positive way? And then go and do what you got to do. And then you get to the point where you've gotten the data that you can get. You don't always have it all, and you just got to lay it out and make a decision for that. And I think that's kind of probably 90% of how it all goes. But you need to be inclusive. You know, we call it inviting, including, and inspiring. You bring a team in, and you kind of get the inputs. That's kind of part of the data that you get, and it really becomes very important to keep people included for that. That's my view of leadership in the normal sense. There's also what I would call, you can call it operational leadership or combat experience, or combat leadership, where it doesn't matter if you go left or right. You just got to get everybody going in the same direction, and you got to do it quick. And so that's a kind of a different type of leadership. If I were in a rocket and heading off to the moon, we'd be in the middle somewhere, unless something bad was happening, and then I'm just making decisions and I'm trying to survive. And so you got to be capable of all of it, and you have to understand what your limitations are so that you can set the right boundaries for doing that. That's kind of my view of leadership, and it's probably a little bit more complicated than you wanted, but it's important.
No, that was perfect. And then just if you can speak to the importance of followership as well, because I know leadership gets
right,
most of the writings, but followership is sometimes more important.
Yeah, that's exactly right. And I've had to flex back and forth. I've been in charge of a lot of people and a lot of machinery in my career. And then one day you just wake up and you're at a job and you're the new guy, and all of a sudden, I don't know anybody here. I don't know a whole lot here, and I just need to be quiet and follow. And following isn't necessarily being quiet. I didn't mean to make that implication there with that statement, but you need to follow. If somebody's in charge, it's hard, right? Sometimes you're making decisions that are extremely challenging. They keep you up at night because you want to do the best job you can for your people. And so having good followers makes it worthwhile. And a good follower is not necessarily just the person that gets in rank and file. It's also the person that knows when to say, "Hey, boss, can I talk to you privately for a second?" And then say, "Hey, I really don't like this, and this is why, and I think we can maybe do it a little bit better for that." And so I try not to raise problems without having solutions, because otherwise I'm just part of the problem. But sometimes if you see a collision coming up, you got to stop it, right? You got to say something for that. So, followership, being a good follower, is a great training ground for becoming a great leader, because it requires great leadership from in your soul when you're following, somebody that's trying to get from here to there.
Perfect. Thanks, Scott. That's great. How do astronauts sleep on the space station, and how do you get resupplied for food, water, or just general supplies?
Yeah, I'm gonna take the screen back. Here we go. And that is how we sleep. Can you see that? Okay, so we have these crew quarters, we call them, and this one's actually in the floor. So I'm on the ceiling looking down. There's no real up or down in space because there's no gravity, but if you had to align it, that's how it would look. And there's 4 of them, and there's both one on the floor, one on the each wall, and one on the ceiling. And my Russian commander came up and said, "Scott, where are you sleeping?" And I said, "I'm in the floor." And he goes, "Where's Nemo, my Japanese counterpart?" And I go, "He's in the ceiling." And he goes, "Oh, Nemo's in heaven and Maker's in hell." So that was kind of funny. So that's how I remember it for that. But, so we got that little sleeping bag in there. The temperature's like 70 and 75 pretty much around the clock. The humidity's down to very low percentage. And we've got great flow in there. We've got a computer in there to do work. It's also our office, by the way. and very small, but it gets the job done. And you think it's hard for 6 months, but it's not. It's nice. Those doors close, and tell you what, some of the best, most soundest sleep I've ever had have been on right in that room right there for that. And I used to actually, if you look down towards my feet, you see from about the knees down. You can't. There's behind it's actually a fan system that pushes the air around and ventilates. But I used to actually curl up in that little square down in there because it really stretched out my back and made me feel a little bit better. And I could fall asleep without floating around and hitting my head and all that stuff. And then a couple hours later, after I'd wake up, I'd climb back into my sleeping bag and just fall asleep. But it's there's no pillow. You don't need a pillow. There's no pressure points. There's no anything. It's just very comfortable and very quiet. So good sleep there. I'll stop the share.
That's great. Let's see here. We have a bunch. You had mentioned your teammates. So how did you manage, how were you able to manage to communicate effectively with crewmates that speak different languages? How did you kind of get over that barrier, or is there certain languages everyone has to learn?
Yeah, so the international language on board station is English. So we kind of had it lucky there, but the Russians are very aggressive, proud people, and we love each other. So we spend a lot of time working Russian. We also spend the last 10 years flying in their vehicle, the Soyuz, and their language inside that vehicle is Russian, 100%. All the switches are in Russian, all the communications are in Russian, the checklists are in Russian, everything is in Russian. And so we actually study Russian at the rate of about 8 to 10 hours a week, with lots of homework beginning the day that we start astronaut training. And so we have to do an OPI, which is the standardized testing for it. And we have to be at least intermediate high before we get assigned. And before we fly, we have to be advanced low, which is, normally we'd call that fluent. I don't call it fluent anymore because after being in the heat of the battle, the Russian just doesn't come through the noggin that fast. But the Russians are pretty good at English, and we kind of meet halfway sometimes when we have to for that. But that's, and you do a lot of, we live there, right? I mean, we do a month-long immersion there when we first get started, and then we train in Star City for 2 years prior, and we're there probably at least 50% of the time. So we basically get into their culture. We get to know their families. We have family friends. We go visit when we're over there, and they come over here and visit us. And we have cookouts, and we're always alternating in between Russian and, somebody will speak in Russian, and then you'll answer in English, and then the Japanese will come in and go, "Konnichiwa," and we get all the stuff going on, and it can get kind of crazy, but it's really a lot of fun for that.
That's great.
Yeah.
So this one is for Abby. She's 8 years old, and she was wondering if you ever did a flip in space, and if so, how many?
Yeah. So yeah, I've done a lot of flips. I've done a couple of them and whacked my head pretty good. And because you got to be careful. On Earth, you have to push up and flip and then land back on your feet. But in space, if you push up, you just hit your head because you don't come back down. So, but you can get really cool where you just kind of just tap your toes and then you just kind of rotate a little bit. And we used to do that a lot at the end. We do public affairs events on station. And if you Google any of those, you'll see usually at the end that they'll do a backflip for you. And so, you try to do 1 or 2 a day anyway, and I remember when I first got there, I was really bad at it. So I had to go in the back room where there were no cameras and just practice over and over and over again. And that's just how you get better.
That is great. How long did it take you to really adjust to life back on Earth, and what was the biggest adjustment for you?
For me, we have a 6.5-week physical recovery program that gets your body running back where it needs to be. My recovery was actually fairly smooth. I'm a short, round person, and we adjust a lot better going up, and we adjust a lot fairly easy coming down. I was very stable. I never fell over or anything like that, and I could walk pretty much right as soon as I got back after 6 months. But you're tired, and your back elongates an inch or so while you're in space because there's no gravity holding you down. And so when you get back home, your back starts to recompress again and take a natural state because now you're back in gravity. that process for me was painful. I mean, it's just anybody with lower back problems knows what I'm talking about. It was really bad. I couldn't sleep for probably about 4 or 5 days. The first night I came back, I had been up for 2 days, so that was easy. But after gravity started setting in, it was really, really painful. So a lot of ibuprofen, a lot of exercising. We have 3 exercise specialists and physical rehabilitators that are professionally trained. They've studied. They've got master's degrees in all of this stuff, and they oversee this whole process for it. And I couldn't have done it without them. It was really painful, but we worked and we got good. So that was the hardest part.
Got it. So this is from Carol. You met Carol when you were on campus a few years back. And it
Mhm.
says, "Hi, Scott. Nice to see and hear you again. We're all learning to live in a bubble. What advice do you have for us after spending time on the International Space Station bubble?"
Well, there's lots of little bubbles that we live in. On the aircraft carriers, that was a bubble as well. And so station for me really wasn't that difficult. We had a lot of digital windows, just like we do today. And in fact, what we're doing today is exactly what I did on station, right? We called down to UMass and we had a good talk, and then we all went back to work. So it's pretty enlightening to go through that process. But for me, I it's about self-care, right? You can't take care of other people unless you're taking care of yourself, right? So if you're tired, if you're hurt, or if you're grumpy, you're not going to be a very good team member. So you got to take care of yourself, whatever that means. Eating the right food, getting the right exercise, taking time off when you need it to communicate with your family, whatever it takes. Yeah, you need to do that. And then you need to take care of your friends and everyone around you, because whether they're acting nice or not, they need you. We're humans. We need human interaction. That's what makes us human. And without it, little things start to happen. And I'm sure that there's some folks out there that have been cooped up for the last several months doing nothing but Zoom and Teams and virtual type things. And your brain just doesn't feel right, or your body just doesn't feel right. And I'm here to tell you, you need the human interaction. If right now we're supplementing with virtual, and that's okay, but eventually we got to hit the street and we got to start shaking hands again and being with each other. Um, the other thing that helps when you're in a tight situation like on station is to just stay busy, right? Have some personal projects. Not everything has to be work related, but you got to have some things that you want to accomplish, some goals you want to accomplish, whether it's making 5 phone calls a day or doing a PR event, or playing the guitar for a little bit. But you got to do something to keep your brain moving, keep your body moving. The other aspect to it is physical fitness. You got to keep your body in shape, or it's just going to be a spiral that you can't get out of. And you don't have to be the Terminator, in perfect shape and lots of muscle and run a marathon twice a week or whatever. You got to do something, and that's for mind and body, for that. And then most importantly, everybody goes through times where they're a little bit down, right? And veteran suicides are actually 22 a day, and you got to ask for help. You don't want to let it get worse. So if you're on station and you're like, man, something's not right, I can't do this. I can't do this work. I'm tired of making mistakes. That's when you have to pull your buddy aside and go, hey, I'm not getting something here. Can you talk to me or whatever? And you do that. And we have folks on the ground that actually help with that. But more often than not, especially on the ship or in combat type situations, you see somebody that's probably not 100% there. It's important as a friend and as a family member and as a team member to pull them aside and go, hey, I'm just checking. You don't have to say anything, but I'm right here. And if you want to talk about something, maybe there's a lot of politics in this program. And so, sometimes we get pulsed to do stuff we don't want to do. And it really makes people mad. And those are the moments where you just want to turn the camera off, go find a quiet corner and just vent. And so being available to do that for yourself and for your friends, ask for help. And that's how you get through it.
That's incredible. Thanks for sharing that. That's great. We have another one. My 4-year-old son Joshua, which is an amazing name, would like to know if you could see Saturn from space.
You can consider, depending on where it is, and I mean, just like Earth, right? I mean, it's about the same size. We're really not that far from Earth when we're looking at the stars and different planets. But we have binoculars up there. I did not see. We don't have telescopes, but we have cameras with like 800 power lenses, so you can actually get some pretty good pictures, depending on the phases, depending on the angles, and depending on the conditions for that. But it's you can pretty much see everything you can see on Earth, plus a lot more. But the level of detail is about the same.
Great. So I know we talked about this a little bit beforehand.
Mhm.
What advice you have for new students as we start to approach that time when everyone's starting to leave or stay home or adjust? What advice do you have for some new students just starting out?
Yeah. So when you're going to school, you always hear horror stories of folks that are kind of get there and it's not what they expected, and they have trouble kind of getting into their groove. For one, just have a plan, right? Just say, okay, this is how I'm going to take notes. This is how I'm going to keep things organized. This is how I'm going to communicate with mom. This is how I'm going to just think that stuff through. Because when you get there, all of a sudden you're overwhelmed. I mean, my first semester was 21 credits, and it was all hard courses, all the calculuses, all the analytic geometries, the basic engineering, all that stuff. And if you're not organized, you're going to spend 20 minutes out of a half. You spend 20 minutes just looking for the information that you need to do the homework, and then you're going to spend 10 or 15 or 20 minutes doing the homework, and all of a sudden your efficiency just isn't working and you can't keep up. And so you end up dropping classes or get a bad grade, or you're struggling. And once you get behind, it's just really hard. So I would just think about how you're going to run your personal business of learning. And because you can really do a lot of good work just to think that process through and to go do that. The other thing is set some realistic expectations. Okay. If you get a bad grade one day, it's not the end of the world, right? You just gotta, hey, you failed on that one. Okay. Go back, figure out what you failed at and try it again. Do something a little different so you get a different result, and then move on. Give yourself room to fail, but be critical of yourself. If you failed because you were lazy and you just didn't want to do the work getting ready for the whatever exam it was or lab or whatever it was, then you kind of deserved what you got, and that should be the learning point, is put some more effort into it. But if you went in there and tried as hard as you could and it didn't work out, go talk to the professor, talk to some friends, figure out what you're not seeing and what you got to do a little bit differently to do better. And that's the process. That's the process. It has nothing to do with the fact that you failed that one and you're going to do better on the next one. It has everything to do that you saw that process and you worked yourself through it, because that's the cycle you're going to go through for the next 50 years. And that's going to make a difference between being successful and not.
I think you answered like 5 questions on that answer, so that was great. I think you all saw it was how do you handle failure. Well, a couple of questions were how do you handle failure. I think he did a great job of explaining that, so thank you. Some of the other questions we're getting are, what recommended paths do you have to becoming an astronaut? Are there any hobbies or skills you think are important if you want to try to be the next Scott Tingle?
Yeah, I would not try to be Scott Tingle for lots of reasons that I'm not going to tell you on a recorded event. The community's changing. It's becoming more populated with more well-rounded people. There's always a need for folks that are focused on engineering and science and math and a STEM-related profession, but it's really being opening up to a lot of different people. The commercial markets are opening up, and I think the opportunities you're going to have are going to be incredible. So what I recommend is that whatever it is you love, just do it with all your heart and be confident. And remember that going into space is an operation, right? It involves technical, it involves people, it involves emotion, it involves everything that makes us human. It's a human spaceflight operation. And so spend some time on understanding how operations work. That could be racing cars, it could be flying airplanes, it could be playing sports, it could be working an IT project that has to integrate 100 different entities and organizations. It could be whatever it is, right? It could be writing schedules for airlines. It could be anything. So get some operational savviness and some experience in your background. That will help you understand what the people are going through behind the scenes to make all of this work.
Great, thank you.
And whatever you do, do it well, because you're going to be competing with other people.
Great advice. This one is about your experience at UMass D. Did you have a favorite professor at UMass D? And what was the biggest lesson or takeaway you may have learned from them?
Yeah, so I had two favorite professors. My all-time favorite professor is Dr. Ron DePippo. He's a thermal sciences, thermodynamics professor, and the best in the world. I've had lots of different schools and courses and things like that, but that he just connected all the gaps. And again, I told you earlier, I came out of a kind of a rundown suburb out of Boston, and I didn't have the best of backgrounds getting there. And he was the one that I wanted to be like. And so he worked us really hard, and but he understood how to bring us along and how to challenge us to do that. And so friends with him to this day. I don't know if he's on or not. I don't have the guest list up here, but Ron, if you're out there, thanks again. I say it every time I see him, but what a fantastic person. The other teacher was Dr. Jay Hansberry, who sadly passed away about 6 or 7 years ago. And he was a solid mechanics, heat transfer. He was talented. He could pretty much do anything, but his talent was coming up there. And like one day he came into class and said, "Yeah, I heard this sound in my car on the way in. I think I'm going to devote my class to this." And he set up, he goes, "I heard this sound. It came, the car listed." He says, "I think it was a strut. I know about the approximate dimensions. So if I start with F equals MA, and then about a half hour later or 45-minute later, he had a theory on exactly what happened and why it happened and how he was going to fix it." And he could just derive anything from nothing, and just talented. And he was very patient with us non-believers at the time, and teaching us how to step through the process of understanding the technical problem and applying fundamentals. And I remember in Ron DePippo's class, he'd give us a problem, a power plant, and he'd give us 3 or 4 variables on it and say, "I want you to go through this power plant and tell me what the input and the output is, how much, what kind of inefficiencies they have, and an overall efficiency for generating power." And we look at this and we're like, "Oh my God." And we would, our study group would get together and go through it. We'd spend 40, 50 hours in a weekend just doing nothing but these problems. Then we'd get in and go, "Well, we got this problem," and we take it down to like 10 significant figures and go, "But it doesn't match up with this 10 significant figure." And he'd look at it and he'd say, "Guys, you're within 10%. You got the right answer." It's a power plant. And he would do that with such a firm handle of the engineering fundamentals that went into making these systems work, that you couldn't not come out of the class with an understanding on how things work.
That's great. This next question is, thank you, Scott. Can you tell us a little bit about sound in space and how you use sound to amplify sound, modulate sounds to assist with long-term occupation of an enclosed space?
I'm not sure what you're asking. Are you talking about, you think that sound's going to be different inside the space station, or are you talking about how we use sound to sleep better?
Yeah, I'll leave that open. Leave it open for Mark if you want to respond over here in the question A section. That's great. How the guitar sound? I guess I can follow up with that. How does it sound in space? Because there's a lot of music.
So sound, if you look at the basic equations, doesn't really have anything to do with gravity. And that's the one variable that we're changing. The pressure inside station which acoustic waves have everything. Everything is about the pressure and the densities and the basic atmosphere. Then we keep the station at about 14 psi, very close to what we would feel on Earth. So the sound inside station is exactly the same as what you would expect in your living room. There is a lot of white noise because of all the systems going on, and there's lots of things that, speakers, working, phones ringing, all the standard things that you think about there. So that it's an industrial complex, so it can get a little bit noisy for that. The one difference is when we go in the spacesuit, we only pressurize to about 5 psi. So we go from 14.7 down to 5 psi. And so my voice right now, you're hearing my voice, but if you go back and listen to the spacewalk tapes, you'll hear me talking like this because the pressure is so low, you get a different acoustic wave.
Great. Let's see here. We got a lot of good ones here. I guess everyone wants to know, do your insides feel weird with zero gravity? How's zero gravity affect?
Yeah, at first. Yeah, but as a pilot, we fly upside down, and sideways and all that. And so you feel funny. It's like being on a roller coaster. And it does, you can feel your insides moving around a little bit, but more so it's your middle ear. And as long as your middle ear matches what you're seeing, you're doing okay. But once it starts getting a little bit jumbled, that's when you start feeling sick. That's motion sickness. And so the first time I felt lack of gravity is, you're feeling acceleration on the launch all the way up until main engine cutoff. And then you're in orbit. And immediately the world went upside down for me. And that's because all the fluids are now rushing out of your body and evening out all throughout your head. And if you look at the pictures that I was showing, my face is a little bit fatter because there's a lot of fluid up there. And I did gain some weight up there too, but that's because of the PB&J tortilla. When you look at the middle ear, that's kind of what's happening. And at main engine cutoff, all the fluid goes up, and it feels like you're actually upside down on Earth, and it's pulling the fluid down to your head. And so I spent the whole first day, or the first several hours, just feeling like I was flying upside down. I didn't feel nauseous or sick or anything. I was just like, oh wow, this is cool. I get to fly upside down for a couple hours. And my counterpart was not feeling so good though. He wasn't used to that. And so he kind of went off into the corner and kind of slept a little bit and did some things. But me and the commander got smarter. And the Soyuz, I'll use this right here. So the Soyuz is kind of flying through space like this. And when you think of a spinning satellite, you think of it spinning like this for stability, which is how we design satellites. So that, for stability. But the Soyuz, because the solar arrays come out like this, it spins like this, right? And so you have the command module, and you've got the living module up here, and the command module here. And so I found if I tied my finger to the middle, to a component in the middle, and put my feet up towards the end, I could use centrifugal force to counter the lack of gravity and get the blood out of my head and back into my feet. And I felt great. I slept like a baby. So that was pretty cool.
That is great.
Yeah, once you're up on station, some people take a week or two to adjust. For me, when I came out, you saw the picture coming out of the hatch. I felt perfectly normal right there. Everyone's different.
Thank you so much for using the diagram or the demonstration, because I was a finance major and I wouldn't have been able to follow. So I appreciate that very much so. Okay. The next question is, did you go into the Navy with an intent to get into a space program, or did that come through later during your Navy career?
So when I was back at UMass, I actually drew myself a little map on what if and else and for a career path. And one of the things I was struggling with is I really liked the sciences and engineering, and I really wanted to go and pursue a PhD, which is why I went to the West Coast after my master's degree to work in engineering, because they had a couple of good PhD programs. But I realized shortly after that I really wanted a little more excitement than that. And And even though I loved flying and I loved the PhD, I had to make a decision because I couldn't do both for that. And so when I looked at it and I drew the map, I was like, well, how can I go through this? And the decision I came up with was, whatever decision I make, I have to be happy that that's the end state. Okay, I do want to be an astronaut. Okay, I want to fly airplanes. Does that mean you're going to go be an astronaut? No. And if I don't make it to be an astronaut, am I going to be sorry that I flew airplanes? And is that good enough? And if my answer wasn't, oh yes, that's good enough, then that was not the right decision for me. So I did everything that I wanted to do, knowing that I might never make it to those ultimate goals, even though they were still goals. And in fact, I applied 4 or 5 times. I never got an interview until my last time. And I was the oldest person in the class, and was like one of the 3 or 4 oldest people they've ever selected. I gave up. I didn't think I was going to make it, and I was happy. I was on my road to command in the United States Navy. I was a test pilot. I was happy. Had a great family, a Navy family that liked moving around and changing houses every few years, and all that fun stuff. And so I was very happy. And so actually getting selected was the icing on the cake for me for that. But you can't go through a career path knowing that, hey, I only want to be the chief of operations of this company. That's all I want to do. I mean, it's just, you don't know what's going to happen, medically, you don't know, competition wise, the programs. I mean, it just might not be available. You got to be have your dream big, go for it, shoot for the stars, but have some reality every once in a while, and be happy with your decisions.
That's great. If I don't ask this one, Anne-Marie, who works in my office, is going to beat me up. So having achieved your childhood dream and now having the perspective of time, what do you think of achieving that dream? And do you feel that same excitement and awe that you felt when you saw Armstrong's first step on the moon in 1969?
Yeah, that's a really good question. And like any other profession and any other human with emotions, I got good days and bad days. And sometimes I wonder, I'm like, geez, what am I doing? It was very exciting, but it's over. It's time to go do something else. But I'll tell you, those are fleeting moments. And more often than not, I look back and say, oh my God, I actually did it. This is amazing. It was a huge amount of work. I wouldn't have done anything different. And I want to help other people do it as well. And then when I go into the meetings and you get pelted with really hard decisions, do you want to be able to control this space vehicle in this phase of flight? And this is the vehicle we're building to go to the moon in 2024. You're making some really big decisions, and that are going to affect a lot of people in an overall mission for a race, right? The human race. And it can get stressful. It can get a lot of anxiety, a lot of things going on. And, you just got to sit back and smile and go, this is cool stuff. I mean, this is like watching Star Wars and being part of the design team, and having an opportunity to really dig into the details and see what's behind the curtain. And the word of caution, sometimes you look behind the curtain and it's not so pretty, but you really got to focus through the noise, through the fog, to that, what you're shooting for that end result. And if you can do that, you'll give yourself some really good perspective. And when I do that and I look back, the biggest thing that I take to heart is all the relationships I've had along the way. There's lots of folks on this call right now. There's folks I talk to every day, different communities I've worked in. We've had, some really tough times out there, some challenges, and we've had some really exciting successes. And when it just comes down to faces and memories, and and relationships, that's the important stuff that makes it all worthwhile.
That's fabulous. And we're going to take one last question. And again, appreciate you, Scott, so much for doing this. And I think we're going to end with robots. And we have a question that says, you had mentioned robots. Can you tell us how robots are used in space? I know there's a lot of prospective students on here. There's a lot of people that are interested in that. So if you could share that piece.
Yeah, let me see here. I'll show you one short video. Was the video working okay, or did it come through as a bunch of still pictures?
I thought it worked fine.
Okay, I'm going to play this video, and this is it kind of ties into one of the questions I didn't answer for you. But cargo, we have cargo ships that come up, and we grab it with a robotic arm, and then we bring it and we dock it to the or berth it to the space station, and then we open the hatch and get stuff out, and then we release it on that. And this is a really short video that shows that process. And let me see, I'll go to share here. Oh boy, there it is right there. Oh, nope, screen 2. Okay, let's see here. Go down. I'm getting it here, guys, sorry. Okay. All right, there it is. Oh God, I keep going back to the same thing. All right, we're gonna motor through it. And you get to see the whole brief all over again.
I'm appreciating it, so it's great. As well.
Okay, here comes. This is Cygnus that came up for us and brought us about 4,000 pounds of food and science. And what it does, and this is, you can see it's going real fast. This process took an entire day. But it comes up, it flies proximity ops, it gets into position, and then we use the robotic arm to do this, grab it, and then berth it. And so that was pretty much that. We also use robotics. Let me see here. Yeah, I unshared, right? Okay, good. We also use robotics to do support spacewalks. So I use the robotic arm as well to support. We had Ricky and Drew out there doing a spacewalk, and we have an attachment that goes onto the end of the leading end effector of the robotic arm, and they stand in it. And I move them around in space. So they're out in the middle of space, and I got the controls, and I'm just moving them all over the space station. And the specific spacewalk that I did that for was incredibly, incredibly difficult. Don't worry about the time here, Josh. It's okay. I don't have anything scheduled after this, so all good. But we had to move them in between a couple of solar arrays and a radiator that we could not break. And all my cameras weren't working because of the sun angles and the degradation over time. And so it was just him talking to me and telling me where to go and what to do. And it was really cool to do that. We also experimented with a robot in Munich, Germany, that was in a facility, and I had an iPad, and we connected through the internet, through the satellites, down to the ground station, over to Munich, and I commanded the robot to go fix a simulated system in the factory. And it was really cool because it put in a lot of, it took into account everything. It was an integrated operation that included new systems, software, people, spatial, awareness, and then operations that, just raw operations. And so it was really cool.
That's fabulous. Well, I don't know if we can get you on the contract to come every year and talk, because I can listen to you till 10 o'clock tonight. But we unfortunately have to wrap up because we're out of time. I want to say thank you. Our entire UMass Dartmouth community is proud of you and everything that you've done, and your name comes up. And it's so funny how many times you'll be walking through and you hear Scott Tingle or astronaut, and how many times I used to talk about you without ever meeting you. You're an amazing person, and we're proud, and thank you for giving back and everything that you do for us. And look forward to the future.
Well, thank you. UMass is my foundation. It's my stake in the ground, and coming back there always reminds me of it. And it's you don't need to think about Scott Tingle, the astronaut. You just need to think about the great education you're getting. And then if you want to talk to Scott Tingle, the astronaut, all you got to do is give me a shout or come on out and visit, and I'll show you around a little bit. And hopefully I'll get back there to say hi to all you guys. But I really hope you all stay in touch. Because like I said, this whole thing isn't really about all the systems and the cool things we do. It's about the cool people we do them with. So Thank you so much for the invite, and I appreciate you getting me out from underneath my COVID rock here.
Absolutely. Thanks, Scott. And thank you, everyone, for joining us. Stay safe, and we will hopefully see you soon.
You bet. Hi
Bye,
to
Scott.
everybody, and thank you. See you later.